Welcome back, everyone. And today we're going to work with texture atlases. And as you see on the screen, I have something that looks a lot like Minecraft. And this is kind of what it is. I found something on Google image search. This is type of an atlas that's used in a game like Minecraft. And the whole point of a texture atlas is to make a single texture file that it comprises of many textures. And this one specifically is divided up as a 16 by 16 grid. So this can actually hold up to 256 textures within a single file. And this is important because it's kind of an optimization trick. So if you think about the whole game of Minecraft, everything in Minecraft is rendered from a single file. So this way you only have one file pushed to the GPU, and you can render the whole game that way. So that's kind of the beauty of it. And in this case, we're going to treat it as a grid, and we're going to use basically a grid coordinate system. But we're going to start from the very top left corner. So for the first thing we're going to do is try to build a TNT cube. So starting at the top left corner, we got to go to the right about 8 squares. And then we reach that red thing that says TNT. And then, so that'll be like 8, 0, because it's row 0, column 8. And, the column 9 is the top of the cube, and column 10 is the bottom cube. So that's what we need: 8, 0, 9, 0, and 10, 0. So that's what the coordinate system that we're going to be using. So now let's go back to our source code. So now on our HTML page, we're going to go to line 41, and we're going to change what our resources are. So we're going to load in our atlas texture, and we're just going to call it an atlas. Now if you go down to line 52, we're going to start updating our shader object. So one of the first things we're going to do is we're going to add uFaces, which is a 2-float vector array. And if you remember, when we build our cube object, we use the W component to tell us what face we're currently in. So this way, we can kind of apply a different texture for every individual face, and we pass it in as an array. So then line 53, we're going to prepare our texture with the atlas that we saved into our cache. And then line 55, we're actually going to apply the array that I talked about. And uFaces is going to be an array. It's a 2-float vector, so that means it's going to be a vector of 2 components, an X and Y. So X is going to be our column, and Y is going to be our row. So like I said before, we're going to need 8, 0, 8, 0, 8, 0, whatever. And each one is positioned, the array is positioned to align to the face value that we're passing in through our VAO, so our vector array object. So, and I wrote in the comments, it's front, back, left, bottom, left, right, top. This isn't the best order, because when we created the cube, I wasn't thinking about making a Minecraft. So ideally, if you're going to actually build a Minecraft thing, maybe the W components will be aligned a little bit better, where you have everything going around the cube, then you do top and bottom. So just keep that in mind if you actually want to do it. You might want to optimize the values a little bit, so this way you can make these arrays a lot easier. So now we're going to move on, and we're going to go into our Vertex Shader. And our Vertex Shader is really where most of the work is going to come from. So there on line 93, we have our vec2 array of 6. That's our uFaces. So that's where we're going to pass in that array of of grid coordinates, I should say. It's a grid coordinate system we're using. Then we go to line 96, and we're creating a constant. A constant is 1 divided by 16. Again, UVs exist between 0 and 1, but our grid system has up to 16 by 16. So this size value allows us to convert from a grid coordinate system to a UV coordinate system, basically. That's what we're trying to do. We're creating kind of like a conversion thing. And then we go to 99. We pull out the W component, which tells us which face we're in. And then on line 100 and 101, we kind of calculate our grid position to a UV position in the texture file. The way that, the math isn't really not that complicated, because all it is, I'm taking the face X and Y position and making it times the size. So let's say if I want the 8th cube, so it's 8 times size, and that gives you the starting UV position for that square. Or you can say the starting pixel position for that square that we want to render. And then we add an offset, which is basically the size of the square, which is 16. So when it's converted, it's actually 1 over 16 to get the actual UV size. Don't forget, we're converting between two different type of systems basically. And we're doing an offset because if it's the left top corner of the UV, it's going to be 0. So it'll be 0 times size, which doesn't create the offset because we don't need that offset, because we want the beginning of the square. If we want the end of the square, when the value is 1, the UV value is 1, if the right top vertex is being rendered right at this point, then it'll be 1 times size. So that means it'll take the starting position of the pixel plus the width of the square pixel, which then kind of gives us, it gives us the ending position of the square. It's basically just like how a rect object is. If you ever use them in other languages or a Windows canvas, a rect object has 4 values. It has an X and Y position and a width and height. So that's essentially what we're doing. We're basically kind of setting up a rect object to kind of define where in the atlas we were trying to pull out of. So, and like I said, we're converting from a grid system, which is 8, 0, and converting it into UV coordinates that will actually grab the pixels. And then at line 102, we just take the UV values and just save them as vec2 values that we then pass as a varying object that goes into our fragment shader. And then if you go to our fragment shader, you have 109, which is just our atlas uniform, and 113 is just that varying variable pulling the texture. And that's all really it is to using an atlas and making a square. So now if you go in a browser, you'll see it renders exactly what you want it to be. You have the TNT Minecraft cube kind of put together. So now if we go back to the code, we're going to do some changes. We're going to go back up there and like back on line 55, we're going to comment out the U faces that we're initializing, because we don't need to initialize. We need now to kind of initialize them in the loop instead of in our prepare. So line 57, you see I'm going to start coming out the cube that we made, the cube model. And we're going to replace that with an array of cubes. So at line 60, the first thing we're going to do is actually just create our cube mesh. We don't want the model, we want the mesh now, because we're going to want one set of geometry that we're going to push to the GPU, and then we're just going to create a bunch of model objects based on that mesh. So this way, we, like I said, we only have one geometry and multiple models, and the model object, all it handles is all our transformations, which is scale, position, and rotation. So it's very optimized. So this way you can create as many cubes as you want, but we only have one version of the cube. So, and that's really what all that section is all about, is just creating the mesh. And then in the loop, we're creating 6 cubes, and each one is going to be a model, and it's going to be positioned in a grid type of way. And I built the grid. The math in there is basically to make a square that's 2 by 3. So that's all that I'm doing, just creating the positions that way. And then line 63, we're pushing our new model into our array so we can use it later. Then on line 71, there's our array that we're just saving everything into. And then line 72, I created an array of arrays, and each one has basically I have like 6 different ones, and each one is going to be corresponded to the same index value of our G cubes array. So the first G cube is going to have the grass dirt, the second one will have log, and so forth and so forth. So I already have those positions for each face predefined. So if we scroll down some more, we have to update our on render. So in line 94, I comment out the render model from our G shader, and don't forget on line 93 to kind of just put the semicolon in there. And then 96, we just render all 6 models. So we're just going to loop through each the entire array, and we're going to set the uniform. So we're going to set the text map. That's basically what part of the atlas we want to use, and then we just render it. And if you go back to the web page, you'll see now we have one mesh, 6 models, and each one is rendering different types of textures from the atlas. And this is pretty much all the magic of texture atlases. It's like I said, it's an optimization trick. This allows you to kind of just do a bunch of things with the same code. It's a really neat technique, and it was kind of fun to learn. And I hope you had fun. And this is not just the ending, really. In all honesty, texture atlases are actually how text is handled in 3D. That one's called a texture glyph, but it's essentially is an atlas, except it just comes with text. And down the line, I'm probably going to do something with text, which is basically it's the same idea as these cubes, except that all of this is just quads, and then you have to create a bunch of quads, and each quad would then have the position on the atlas or the glyph texture, and that's really is essential. It's kind of like the glyph is kind of like a mix between a texture atlas and a texture mask, because since it's all text, it's just going to be a mask of the actual text. So this way, then you can just color it. It'll be just like a black and white type of thing, or transparent and white type of thing. It really depends on how you set up your texture glyph. So that's essentially it of all today. Hope you enjoyed it. Hope you had fun. So now that you know how to make multiple cubes and how to render them with different parts of the texture atlas, why don't you do something fun? Do some animations with cubes. See if you can make a giant, thing that's Minecrafty. Since now you have all this functionality here. So have fun, and see you guys at the next lesson.